Hey guys, welcome back to another episode of the Real Hacker Hours podcast. Today we're going to continue work on the static bug finder, and we're going to work on the problem of identifying if a particular, a Varnode is from the stack. Now, how I've done it up to this point was I just looked at a pointer sub operation and just automatically assumed that the output was a stack Varnode, and for the simple test cases I've been running, it's worked. However, the issue with this is the pointer sub pcode op isn't strictly tied to stack addresses only. It can also work for a heap from my understanding. So I needed to change this. Already started a little bit of work on this, which is right here. So one thing about the Ghidra, the function, what do you call it? The function data structure that we have is it has a function called .getLocalVariables, which should return an array of the variables, which variables are a Ghidra Java API object. And we can see that they're printed here. And we see here it says stack and stack. So what we should be able to do is what I'm imagining is when we're setting up a code iterator, or when you're looking at a function, we can just have a little bit of code that'll just iterate through all of the variables, check if they're a stack, which let me look at the Ghidra Java docs real quick. Give me a second. Okay, there is the Ghidra Varnode class does have a function called isStackVariable, which should return true. So we should be able to just iterate through all of the local variables, use that isStackVariable to check if it is a indeed stack variable, and then we can store it in a hash set. And then from the variable, we should be able to get the offset, and the offset should be the same as the constant being either added or subtracted. So let's try with that. Right now I'm just working off of the pointer sub, what do you call it? The pointer sub if then statement in the code iterator, but let's continue working from here. Let's see. Vx dot is stack variable. This should return true. Let's see if it does. Okay, we can see that both of these are true. Let's have the next thing get stack. There is a function called getStackOffset. I want to see what this returns. Hopefully it returns a negative. Vx.getStackOffset. Here it turns negative 16, which corresponds to that, and negative 120, which that should be what this is. Yep. So we got that. The next thing that I'd like to do is, let's see. Where's the pointer sub? This is the pointer sub operation we're looking at. We're going to have to look at this particular input, get the value from it, which will be this OXFFFA, and then convert it over into a signed integer. And then that should be this negative 120, but let's get that working first. So we can get Varnode, what's the right word? Varnode offset equals inputs 1. And let's just go ahead and print out the offset first. Excuse me, I had to sneeze. Okay, let's try this. Okay, we're seeing that it is printing off the offset. Now I'm going to look at the Ghidra Varnode docs via just Googling it in another tab outside of what you guys can see. Ghidra Java Varnode. Let's see. Is there like a get offset, get value, get address? There's get word offset, get space, get size, get PC address, get offset. I'm pretty sure that's what I'm looking for. So let's print that off. Inserting some new lines there so it's easier to differentiate from the other text I have being printed. If I had to guess, it's probably going to print off the OXFFFFF whatever 88 as an unsigned integer in base 10. Oh no, it printed it off in actually just the negative 120. So this is good. Next, you see that it's printing off negative 120, which is equal to this. Next thing I'm going to do is just to make sure that this works is I'm just going to store this as a long variable and just do a comparison with this. So let's go ahead and do that. Offset val equals offset dot get offset. Actually, first we should probably do a check to see if it is constant. So let's actually, this should be offset Varnode, and this will be if offset Varnode dot is constant. Reason why I say that is, as a general rule of thumb, actually, this is just a non-horrible coding practice, whatever. Offset to the stack should always be constant, at least when you're defining a variable, because it needs to know how much space to allocate. Well, the compiler needs to know how much space to allocate when it's actually writing the code. That's why we have malloc for dynamic memory allocation. So this offset should always be constant unless something is just horribly broken. Unless if it's doing, well, I'm thinking of some edge cases, or at least this is what I'm thinking. So, moving forward, offset Varnode long, and then we should be able to comment on that coming up then. Gonna comment out this, comment out this, commented out this, but I am going to just print a comparison between offset val equals vx dot get stack offset. This should print true for the negative 120 and false for the negative 16 one. Did I save it or something? Oh wait, I did equals not. I did one equal sign, which is used for assignment, not two equal signs, which is used for a comparison. Smith-Berry mistake on my part. Okay, we see that this is true and this is false, meaning that we can effectively use this for a comparison. There's no real type conversion shenanigans that we have to deal with or anything else like that. So this is good news. Next thing that we need to figure out is where we can actually initialize this, or the process of actually enumerating the stack variables. For that, I think the most important thing that we first need to do is identify where in the code base we actually go and check, is this a stack variable? I think in the main file next I have a function called is varnode from stack. And it is called from the current context that we're seeing from here, which that's from here, which that's good. Let's also check from here is Varnode from stack. No. Okay, cool. So it's all done through here. So this is good news. What this means is current context. What we should be able to do is the contexts are. I'm just gonna double check that all the contexts are spawned in the code iterator. If that is the case, then I should just be able to, whenever I initiate a new context, either if it's for if it's not for a function I've generated a context for before, I should be able to enumerate the stack variables and then save it for the context. And if it's a context for one that I have already enumerated the stack variables, I should just be able to copy it. Okay, for this, let's go ahead and make a hash set. Actually, stack varnodes already have that. So, what is the context? Is the equals. Okay, I'm gonna just make sure that I'm not defining any in here without my knowledge. Generating context. Okay, no. This is the only spot that I'm actually generating a context from. So, what do I have here? I have Varnode, stack Varnodes. What I'm also going to want to do is have a, and here we have the calling func. I want to define that. Calling func. This calling function is calling func. Okay, so this way we define that because the variables are tied to the function, or I want to pass that to the context, since the context is what's actually going to handle. Oh, will it? Yeah, let's just do it all in the context just to make it simple, at least for now. When I'm fine-tuning this, when I actually get like most of the functionality done and actually trying to like get this code to be all steamed out and remove inefficiencies, I might move that functionality to a different piece of the code base, but for now I'm just going to do it all in the context. What does that leave me? This calling func. Let's go ahead and put Varnode is. There should be like a is dereference to get all stack Varnodes as Varnode sign compared. What did I? Let's go back to pointer sub. What was the function? Oh, I just directly put it in the hash map there. Okay, I'm gonna want to change that. Let's make a function here. Private void enumerate stack variables. So how are we gonna do this? Variable array local vars equals this dot calling func dot get. What is the function again? Get local variables. Okay. Get local variables. Quick check if local vars is equal to null, return. Then we're gonna iterate through each local variable of the local vars. Do a check to see what is the is stack variable. Is stack variable. Actually, I'm going to just do, if it is not a stack variable, continue on to the next one. That way we don't have a lot of tabs. That being said, moving on to the next one, what do we have? We have to get the offset val. long offset. Wait, what is it? Stack offset is equal to, what are we putting this equal to? Let's see. It's going to be equal to local var dot get stack offset. Just realized that this should be v. Also just realized there's going to be a slight difference in how, there's going to be a slight, difference in how I use the stack Varnode function, because now I'm just looking purely off of the offset, not the, what do you call it, the Varnode itself. I have an idea of how I could potentially fix that, but I'm going to need to make a change or two. And then we're going to put it here. I'm going to change this from stack Varnodes to stack offsets, because that's more, that's effectively what we're storing here. And there's going to be a hash set of integers, not varnodes. Okay. This being stated, we can go back, where were we? Here, now we can do this dot stack offsets dot add stack offset. So this should enumerate a hash set containing all of the stack offsets for the local variables of a function. Now we need to fix the situation where, like, the is stack varnode. Oh, that's the code iterator. Where is phalanx? Here it is. Is stack, is varnode from stack. They're passing in a, they're still getting a varnode, not a value. However, what we can do to where is this? Is stack offset. First, I'm going to fix this issue. Well, what I'm going to do to fix this, so this right here is effectively the comparison where I check to see if it is a stack varnode via does it exist in my hash set. I'm gonna change this to from just simply checking it to varnode. Actually, I'm going to look at the defining p code for the varnode, because, like, for this pointer sub, it outputs to this varnode, and if this, where is the call? Yeah, we're seeing that this varnode right here is the actual destination. So this varnode is what we're actually getting from this function call. What we can do is we can just look at the defining p code up for it, and if it is a stack varnode generated from a pointer sub or a pointer add, which from my current understanding, those are the only p code ops that should actually be generating a stack varnode that we're looking at. We can just look at that defining p code, look at the offset varnode, and just check there, is this in the hash set, and if it is, mark it as a stack varnode. Okay, let's continue on with, actually, I'm gonna pause the stream for a second. Okay, I'm back. Let's get back at this. Where was I? Where was I? Let me think for a second. Oh yeah, I was rewriting the is varnode from stack. P code up, defining p code equals current varnode dot get def, defining p code does not equal to null, you can get a Varnode def p code inputs equals defining p code dot get inputs Varnode offset Varnode equals defining p code. Oh, wait, or should this be def p code inputs? Let's see, it should be the first one. The first one index being, well, starting from 0, 1. That's what I mean by first. It's the second one. Oh, confusing. Now, where does that leave us? We need to get the long offset val equals offset varnode dot get stack offs. Wait, no. Should just be the offset. And if this dot stack offsets dot contains offset val, return true. And that should be it. Let's see if this works. Probably made a typo somewhere. I did. Looking at it here, I'm not seeing an error that stems from one of my source code files, so I'm just going to try analysis. Class not found exception. P code defining P code. I'm going to try to comment out some of this. Let's start with this. Just commenting out basically all of it. Okay, now we're getting some errors that we can work with. Oh, we got rid of. Oh, I see what the issue is. I got rid of one of the starting brackets, but not the ending bracket. Is it this right here? Let's uncomment this if it does not equal to null. Actually, it's probably the get def function. If I had to guess, it's probably that being wrong. Let's look up Ghidra Java Varnode. Is it? Yeah, that function is get def. No, I'm just gonna comment out all of this. Nope, not that. I'm just gonna also, I just realized another issue here. This dot narration context dot stack. We've gotten rid of this this value right here. So that might be causing an issue. This is partially also why I like to run the script once every time you change it. That is not the issue. This is gonna be fun to fix. What is this issue? No pointer exception. Just gonna comment out this. Oh, I'm pretty sure this is the issue right here. Let's try running this. Okay, so that wasn't the issue. I'm just gonna Control Z, just undo my changes until I get back to a state where I can actually run the binary. This start calling the function equals then. Let's try this. Oh, so when I say run the binary, I mean run the tool. Okay, got it in a functioning state. Let's continue doing this. For variable local, might be an issue with this function. Let's run it once to make sure that those two lines of code aren't a problem. Okay, that is not. Then let's go ahead and get long stack offset equals local var dot get stack offset. I believe that's the name of the function. I'm just gonna try running it once. Okay, that worked. I'm gonna go ahead, instead of changing the existing one, I'm gonna first introduce a new hash set and then transition over there. That way I can slowly move over the individual calls to it one by one instead of just switching all of it at once. That way hopefully less stuff breaks on me without me knowing why. Okay, cool. That worked. This dot stack offsets dot add or dot put. Well, no, this is a hash set, so it's dot add. Okay, let's just run this function. If this function can run, we should be able to effectively enumerate the offsets of all stack variables. Is it just the... Just watch, that's my entire issue right there. No. Hang on 1 second. What is... I'm gonna look at the Ghidra Java Varnode variable. What is the actual return? I think I'm pretty sure it's just a get stack offset is an integer. This should be an int, not a long. Pretty sure that's what the issue is. Yep, that's what the issue was. Okay, cool. Now let's go back and rewrite this. Pcode of defining pcode equals current Varnode.get def. If defining pcode does not equal to null. Okay, if it does not equal to null, Varnode inputs is equal to defining pcode.get inputs. Actually, first, if, well, no, we can just run the check on the length of the array. If inputs.length is less than 2, greater than or equal to 2, Varnode offset Varnode is equal to inputs of 1, and offset is equal to offset Varnode dot get offset stack offsets dot and here's where we actually check if the offset does exist within the hash set. Okay, let's try running this. There's an issue at line 130. Issue outline right here. This dot calling func. Oh, issue being right here. I'm gonna change the song I'm listening to. Okay, what's going on? Line 130. Iterating to call func. Why is it doing this? No class def found error. Oh, this is gonna be fun. So it's printing out this stuff, which means that what happens at 130? The fact that it's printing out this stuff means it has to at least like run successfully at least like once. New context. I'm gonna try just changing the name of this. Maybe, I doubt it, but there might be some weird issue going on with that. I'm gonna change this from calling func from this.calling func to just calling func, since the function is being passed in. It should work. Probably isn't the issue, but oh well. Oh, this should be 3 L's now. Another issue. Arrayless context. Get offset. Okay, so this is a bit interesting. This is a So this is a long. Now, when I initially did the comparison in code iterator with pointer sub, I used long if I were offset. Yeah, so I should probably change this from an integer over to a long. Oh wait, this is going to cause an issue right here. I knew it. Okay, let's see what the first issue is. What did I do here? I'm going to look up Java convert into long. So apparently it's long dot value of. Long dot value of. Let's try running this. Okay, so that seems to have worked. Okay, to test if the stack Varnode thing really working now, I'm going to change this over from code iterator to all references real quick, just to verify that, since the current method we're doing right now doesn't have support for actually checking functions, since I removed that temporarily. Let's see if this works. Wouldn't be surprised if it broke 30 ways. So it didn't break. Yeah, it didn't flag it. Okay, that's interesting. So, more stuff to work on. Fun. Let's switch over to code points for now. What I'm going to do, well, let's first make sure that it can flag this. So let's switch this back over to all references. Also, let's pop open the test case itself that we're looking at, because I forget exactly what the context behind it is. Oh yeah, just getting it directly into a stack Varnode, and let's see why this is not working. We do not need the P codes anymore, so what do we need? Let's get rid of some of the, well, what's the big one? This print statement is the one that's permanently printing out most of the text, so I can get rid of it to clean this up. So it can have more print statements and figure out why this isn't working now. Let's go down to analyze fget. So, I'm gonna insert a print statement right here since this this else condition should be executed because this function right here analyzes an fgets call, which is what the test case is for. This if then clause is executed if it is a variable rate, which is not, it's a constant rate as you can see there, so this should work. Okay, if you see this print statement right here, that means that this function, actually, I just realized. Oh yeah, if you see that if then clause is being executed, which is a good thing. So this is being executed, that is good. So here's the context. Is it calling is Varnode from stack? It is not. Is it getting down here? I wonder. Dot print line size plus size stack space. So it isn't even getting down there. Okay. Oh, pretty sure it's this. This is the issue right here. Get all stack var nodes. What it? Oh yeah, that's cause some issues. So I can see definitely what the issue is here. We're calling the get all stack of our nodes, which should return with the original design. It should return an array list containing all of the stack of our nodes. However, we're only keeping track of the offsets. But this is the read static. Okay, yeah, same thing here. Get all stack var nodes. So, what was the plan here? Get def, get stack var node size. I have the destination right there. I can just check. So, in order to get this working, what I can do is I have the destination Varnode right here. I can just look up, is it a Varnode from the stack? It is. Cool. Then just get the offset and check it with the size. And then that should tell me. Let's do that right now. Okay. Current context on is Varnode from stack. It should be ran multiple times, but well, since it's looping through, well, maybe not. There should only be one call context further, so it should only be ran once. But it should return true. which it is not. Okay, this is where it's getting interesting. Let's look at is stack. What is Varnode from stack? Let's print out the defining P code. Defining defining P code equals this, which is should be able to get this. Should be able to get the offset. And I'm also gonna print out, might be the issue might be here. So this should tell me the offsets that are being added to the hash set along with the offset that's being looked up. I should be able to easily compare the two. Oh, this is the issue. It's not calling enumerate font. Oh, enumerate stack variables. Classic smooth brain mistake that I make. Okay, it is now saying that it is a stack variable, so that is good. This now I just need to change the algorithm so I could effectively account for the new way of doing things. But this episode has been going on for over 47 minutes, so I'm gonna end it here. Thank you for watching.